Welcome again to Wickerson Studios. This video is for the GH Python private group of developers for 2.6 thousand members have jumped on in the past few months, and I've returned to GH Python script, and I want to show you why I did that. I know a lot of you know that I moved on to C programming, which I did to learn how to write GH Python in GH Python better. I want to show you an example of why I've kind of gone there. Now, this is a collaboration sort of with Ralph Schroeder from ARA Jewelry. I send him some very simple scripts, and he jives them up and activates them with the AR Jewelry apps and what can be done, and really produces some beautiful geometries. His system of pulling things together is very easy to understand. If you sit and go into it, it is organized. That's what I mean by easy. My method in the middle, as you can see here, is what I hand him, and that's the chaos that you get a little bit more at Wickerson Studios. So this little nest egg in here, and I've added a little bit of gene pool to it just as we speak. I do that because if we take a look at this in detail, I've just applied what a very simple C script can do using trigonometry, and edit these snaps and pull this one back to 0 count. You can see that as I rotate through this, what happens to the geometry on top of that surface. And it's all trigonometrically controlled, and it's because it's running a very simple C script that generates some very interesting geometries. Let's leave it down here at 4, kind of like that one, and show you exactly what I've been doing with Ralph to show him what's actually happening. So if I send him a C script and I show exactly what's happening there and what's being generated, we're going to go off here and we're going to jump into shaded. And this is going to lead into a series of Wickerson Studio type plugins for GH Python. I'm going to show you 10 to get you started. So hold on to this video and see where it goes. But the reason being, when you understand breaking things down, that it's simply a control of things like this. Let me take this to disable. And we're looking at the curves being generated by a very simple C script, which you can find online and customize. It basically creates a list of points and then does an iteration through them in drawing them out using the sign components and the math component, which is fine, and usually end up with a series of points and a point list. Well, what's nice is in these 3 little ways of constructing, create from points, create from curve, create from loft, you're able to make this node, this C node, output curves, surfaces, and lofts. And that's where I'm going for in the GH Python node scripts. So you don't really have to understand this fully, but it does output this series and 2 other surfaces. This one's on disable right now, but you can see that it produces those 2 surfaces that kind of miss each other and these curves. And of course, the power of that is as you get in there and you start to run through with the sign unit, which I decided, I took a look at my initial one, which was fairly interesting, and it has a subtle, real nice approach, to rolling through this sine curve and getting some beautiful surfaces. But I said, well, what does it do when you go from -1, which is really dealing in sine, all the way up to +1 and roll through 0? Well, you can see you get all those kind of jazz and jumps. And in doing so, I said, well, there was quite a few in there that looked interesting, so let's put them into a gene pool, set them so we're not going to disturb them, treat them as multiple sliders, and just pop through and say which ones do you want to make your surface. Of course, number 4 looked pretty interesting, and in doing so, you ended up enabling not just this as a surface form, but also this as an actual ring form. And there you go. Everything else comes with learning ARA Jewelry, which I would say get online, get copies of it, look at the handbook, find out how to get into it. It's where I feel that all the other making of objects can be driven by very simple point generating scripts. Enough said. I'm going to have to move this face over here. That's a lot to talk about. I know Ralph's been excited about what I'm doing. I'm excited about what he's doing. I love the way he activates and gets things going for me. What I'm going to do is I'm going to go in and show you what I'm working on. And it's basically jumping in here. It's not going to produce too much but data and some point systems. So I'm producing this series of what I call, let's go over here first, producing this series of nodes called WSGH Python nodes, which are actually compiling my nodes. So when I pull them out of here, say this test, you can't really go in and get anything. All you can do is go in and hover and say, okay, what is this looking for? So as I click on that, as I double click this node, nothing's happening, but it is telling me It's an empty point parameter. So if I set a point parameter onto it, something would happen, and it would output for me a symbol of 3 lines drawn. The symbol drawn is 3 lines. It basically makes a 3-dimensional crosshairs. And that was my first test. But what I want to run through is how I create these nodes. And these are my top 10. One test, and then one for a range dealing with data. A lot of point systems, 2, 3, 4, 5, 6. A point system that is intended to generate curves, 7 and 8, 9. And I guess that'll be the 10th one if I include it. And then these are making rippled meshes. Now, there's not much to look at there. So let's get out of that and jump into where the magic really happens. And here's where the magic really happens. So we downsize this, we upsize our project window, we zoom out, and all of these geometries are being made by these very simple nodes, as long as I put in the right plugins. And they're all up and running, and I'm thinking I'm going to do a point system, a curve system, possibly a mesh system, and that'll be about it. Maybe some surfaces, maybe some reps, but I'm going to keep things dead simple because I want to get into the math that drives all of this. Now, the first example is pretty simple. I went online and I found a Python script that built crosshairs, and this is how it's written, and the author was Piak. And it's an example of things that are hard-coded in, so they're not really that playable. But that's usually what I'll start with. After I do those, if you go to this file and you have it open and you hit mode and shift it over to, I'm just going to drop this down a little bit. If you shift the mode over to GH component SDK mode, you're going to software development kit. You're going to all of a sudden have it fit, and you'll have to do some minor changes, which you can find online, which are fairly simple, moving your imports up around certain areas. And it will return a function from a class, so you can actually run this as a script, which is pretty amazing. And you will see it like that until you take it over to compile. Once you take it over to compile, it will be generated in a way that you won't be able to open it like that. It will be closed. So an example is, when you take it over to compile, it's going to ask you all the information to actually build yourself a wonderful plugin. And there is the plugin. So not only can I be susceptible to those points driving this plugin, let me turn it on, preview on. I could take a point cloud here, and let's just grab 12 items in that point cloud, point count 12, and plug that in. You'll see there's all my crosshairs that are existing, and of course with a seeded function. Let's choose another seed, and I have it on hidden wire. I'm not sure why. You can see that I can do-si-do those 12 around and jump and build these wonderful geometries. And that's my test. And that basically is opening a file, going into the software development kit, and compiling. You won't be able to compile if the out is here, but I'll leave it up to you to walk through on the tutorial how to do that. What I ended up doing was taking all of this, and let's just take that to disable. I then started thinking of some scripts that might be interesting to me. And here's how you walk through it. Enable. So I found a script that was pretty simple. It outputted hello world, which is pretty easy, just to test that my out was working. And that was my and then I just showed an example of a comment. And then I added a point, but instead of hard coding it in at say 10, 2, and 8, I decided, well, let's just bring it in as inputs. So I have to go in here and I have to make sure these match the data. And how I end up listing these type hits and access is how it will then read when I go and shift the mode to Grasshopper component SDK mode. And in doing so, it ends up looking like this. So it jumps directly over. I think I'm going to pocket this guy. No, that's me. He's going to be in the way the whole time. Basically, it is taking that script, moving a little bit of these. You just have to make sure that you have your imports up above. You can put your comments above what's actually happened. And I said this prints my first string script, hello world, and outputs a point A. And that's exactly what it does. Now, when it's in that mode and you go to compile, it will ask you all these wonderful things that you can end up importing your own icons from your desktop, say, which I have set up. And I do that repetitively, and I'm willing to show people, go into more details on this if necessary. But you're left with a script right here that you can't open. And when you pull it off where you're working up here, being that this is our first data example, anytime I want to go in and use that, that was not the data example. That was my example of hello world point, which was I actually thought it was my data. not my range, which was data driven. Maybe it was my hello point. Yeah, that makes sense. It would be in points. And there it is. It's not running until I plug in my data to it. And anytime I do that, I'm going to generate another series, another point that's out there and be able to use it. And you'll say, well, I don't want to produce something that's, basically outputs a name, but you're starting with your first plugin. And you'll realize how things get more complex very quickly as we do-si-do through this. So just bear with me another minute. Number 3, this is something that always bothered me, and it's frustrated me for a little while. It's the fact that in Python, as opposed to C, you can't really get into doubles and decimals and all these other things. It really, in the range function, it's very hard to negotiate around what's actually happening here. So what I've got is it deals really well with integers. So this function, and I've got a nice link here that will tell you all the history of why Python does this and how you can get around it by scripting differently. But here's my first script that basically says this is going to be an integer tool only. And I have to input all of these as integers. And even though you don't see that in writing your initial script, start, step, stop, and instead of having it hard-coded within here, you can append a list by creating a list and output that list. You'll see here, as soon as I go to the SDK mode, GH component SDK mode, it's going to come up reading like this. And at this point, I wrote it again, but I said, well, there's a workaround. There's a workaround with a definition float range, which I started to see online, that you can import decimal that will allow your step to at least work within a decimal. But you'll see that these functions start getting to rounding problems very quickly. If I take this up to 0.6, you start ending up with some really nasty numbers, which is why you'd probably use your range tool that's already set for you in the tools. But you're learning problems with scripting and coding. And then what I did here is I went farther in and I realized, okay, I could really make this work if I imported num, but I don't have NumPy imported, so I'm starting to get a red flag. So all I did was go back to my original script, make sure I took that initial one, start, step, stop. I called it the Wickerson Studio integer range only, and it functions as an integer range. It's got my logo on it. It's for dealing with generating data, which is why I put it in this section. And I can pull it out, and I can continue to make range after range after range, depending on how I want to do it. So it's a tool that still says so basic. People say, well, why even learn this? Well, you'll find out why soon enough. Let's take that number 3 and take that to disable. And I'm willing to walk through with anybody in the Patreon that wants to talk, and certainly in the GH Python group, the why I'm doing this, any details, and see the other developers that are finding it interesting. This one's nice because there isn't a node that I know of that does this right off the shelf or off the ribbon tool, unless you're working in plugins. And here's an example of that. It basically was a script that I wrote because I understand enough using Rhino script syntax. I'm not even getting into harder namespaces or Rhino Common, really. Basically generating an empty list, taking the range through X, which would have to be an integer, because I've realized I have to stay with integer ranges. You can't use F range. You can do something in Rhino script syntax, and I'll show you that later. Then I do another iteration in the Y example, and I'm going to stretch out my I's and J's as my points and append those points. And we're left with a pretty interesting array that I can play off of and change. And that's a pretty good node to just grab off the shelf for generating points. And it's a 2D grid. Now, how did I make it into that 2D grid? Well, I continue. I took it down here, and I made sure I plugged it into the mode, which has got this little puzzle piece here, which I love. The Grasshopper SDK component. Before I took it to compile, I made sure all the information was right. And there's the compile mode, which no information can come in. When you pop out the 2D grid, it will ask you for, it will say within it, the script input, what it requires. And I probably should say, it says set integer, which is very nice. If this was not set, that's very nice because you could actually go here and click that and set your integer to whatever you want. Clicking that, and then you'd have to set a number, and then it would take it right in. But I'm much happier having things be much more parametric. And so there's my grid highlighted blue that I've actually taken off and written with my own node script. So now we're getting a little more complex because these nodes are not easy to find and right off the bat in the Grasshopper ribbon tools. So I hope this is starting to make sense. Let's find out what I did in the next one. So I enabled this one. I did these all this afternoon. They didn't take long. Now that's hard to see what happens. But what it does is it's a pretty cool tool. It's got too many things open right now, so I need to take this one to disable. The first tool is pretty simple. I wrote a script that uses I believe, a conditional lift is what I call this node. And so it's for generating points that would make a pretty interesting curve, and a wobbly curve at that. Taking a look into it, I probably have deleted my initial mode because that's becoming a waste. No, I already took it into my SDK mode. And as you can see, I wrote my initial script and then I had to pack it in here. But what I'm able to do is generate a series of curves that not only start and stop, they also stagger, and I have a height range on how they stagger. And that's a wonderful tool for thinking about taking over into your interpolated NURBS curves and polylines and things like that. So you can see how that has an effect of, well, if I don't put it into degree, for one thing, let's take that out of degree and make sure we pop it into the vertices. You can see how you have a very nice curve that's going to be different from a NURBS curve. But in time, you'll find that we start scripting things about curves and surfaces within this node. But right now, I'm trying to control data. So that one's done. And then what I did was after that one was gone, let's just take these and go to, let's take this one off on group. Let's take this one and hit that to disable. And this one we can enable. And this one is basically my node system that I decided what I did is I wanted to call it size and lift. So it means when you're writing, you can start to really make sure everything you need is tucked away in it. You will have to do some work not only moving your imports, but also going and typing in your attributes as to what feeds that function. So I had to change my XY to size and lift. And of course, that starts to make a lot of sense. And believe me, C# really helped with why these things have to happen in Python, which I had no clue of before I went into C#. Anyway, that's another one. We'll group that whole thing, and actually with the number as well, and we will take it to disable. And this is where things start to become a little more jazzy as we go. The next one is, let's take enable. This is a nice one that has the same data, but I called this one a conditional stagger because it's actually not just lifting, it's staggering out numbers as well. So I start to name things in a way that I understand them. And the only difference between this one is it's written for everybody to see, and it's SDK mode, but that's not what I'm going to give people as tools. I'm not going to send those out. I'm not generating those. What I'm generating are these nodes which actually don't have a breakdown of what's happening. So to learn these series, you have to do it on your own, but to start playing with Wickerson stagger nodes, it could be fun. Now, it's not too exciting as of yet because we're not turning it into a mesh or a surface, but you'll see I can stagger those points which affect the curve. And the one thing here that's having an effect is this one's staying. But this one, you can see the stagger starts to move that in its number and range. It's allowing me to start and stop the step conditional this way. And if you think of these as profile curves, it's actually a wonderful way of controlling data to generate lines. Points control the curves. And I've just thrown it into here so you can see what the outcome is. So now it's getting a little more interesting. Disable. The next one is referred to as enable. And I'm going to take this bottom one off. Disable. You can see that now I've ended up making something very exciting through very interesting means. And that is basically either choosing to produce a point system, a wonderful curve system that's generated from that, and look at the complexities of the mesh that's within it, and look at the complexities of the surface. So surface is tremendous. Mesh is amazing. For those that stuck up this video to now, you see what I'm getting into, and curves and then points. Now the script, I've also, funny enough, had a nice script that I wrote earlier called check if it's prime. And the reason I did that was I wrote a script that is pretty interesting in how it pulls out a kind of helix form, but deals in a lot of low probabilities, high probability maths, smaller sizes, larger sizes, and dividing lines. So I took what I find online and I complicate it by writing my own script that means something to me. And not only that does it mean something to me, but all of these attributes mean something to me. High, low probability, smaller size, and divider. So if you do that, and then what I did here was just to make it interesting to make the surface, to make this work, you have to play with the UV count. but I did take it through a couple of index points. They don't all work, but they really do generate some interesting surfaces as I go, and they always generate a very interesting mesh because meshes work so much different than surfaces. And your curve is always tremendously just fantastic to think about how would that drive forward as a mesh and as a surface. So a very interesting script, and that's not even getting into this, which is pretty infinite on what's happening, and then you can also stretch and elongate this form. So it is a powerful script as you watch that curve, do-si-do curve all over the place. And of course, what I've done is take that to disable, and I've taken this and clustered it into my own node that nobody can access. But if you want to get a Wickerson Studio crazy helix, you go over to Wickerson Studio's point generation, which might be under meshes. No, those are the I call that Ripley mesh and Ripley conditional mesh. It's Ripley curve. What did I call it? Crazy something. Crazy helix. And there it is. It doesn't run until you start putting these things in. And if you look here, it says an integer. You'll state that. If it says low probability and high probability, I'm assuming you mathematically know that's between 0 and 1. And then the smaller sizes are just something that will play off the size, possibly as integer. And your division, you can play with any number you want, float, to make it work. So that's how I'm thinking about my forms and starting to think of my own custom plugins to make geometries. And I think they will inform jewelry, architecture, sculpture, and what have you. Let's continue. We're on to 8. And I've got 10 here that I wanted to walk through. So let's enable that. Pretty nice. I'll take the bottom one off for now, disable. But what happens here is I called this one number 8 was called a Ripley curve. And that's exactly what these points make. They're just a Ripley crazy curve. And without seeing the points through a curve system, look at the magic of this, which runs off a very simple script that was written in the last one. A size, a trig factor, which is amazing, because if I start messing with trig, I really start to jumble and accentuate that. If I start closer in, it gets rid of that inner circle. It also flattens thin and wide. The outside has to respond to that. The smaller surface will behave in relation to the larger surface. And I've got 429 points here revolving. So very exciting form. And when you start looking at it as a surface mesh, which you could turn it into a surface, but I think as a mesh, it's a very nice tool to start thinking of that as some crazy landscape that has this really interesting fine flat mesh points in the center. You start wrapping these things over top of other forms, you're going to have some really nice geometries. Let's take that one and put that to disable. And then, of course, enabling this one allows it to run again. And you can see that I've got it tucked into a Ripley curve, which I actually put under points. I should probably start my curve, but it doesn't generate a curve. It actually generates points for a curve. Ripley curve comes out, and you basically have to put in your inputs to make it work. So they're Wickerson Studio nodes that, for me, work with a lot of maths and make a lot of sense to me. And they're boring to most people that need, a fancy name. That's basically what I've got figured out. So this will just keep getting more and more complex as we go. The next one, number 9, maybe I'll leave the bottom off this time and just take this one and enable. And this is a Ripley mesh, once again. It outputs points, but I thought because it works best on a mesh, it might be nice to see. And this is an example that I took the script, but not happy with the actual script of being hard-coded with numbers. I thought I could translate those into numbers that had variables that meant something to me, probabilities again, factors, modulus A, modulus B, and changes that occur within it. So what I see is something that produces a very interesting mesh and behaves with what these numbers would imply. You can see there's a lot of power to this. I will take all of this to preview off and then take the mesh to preview on. Yeah, actually, I could just click on it. You'll see you have a lot of power within here to have these forms very nicely displayed. Actually, I could probably take it off and just click on it. And you can see that you have this wonderful wave pattern that occurs because of conditionals on a surface and undulating. Fantastic patterns. There's no beginning and end to this, and I have to give credit to the algorithm, which I can find online so often. But really taking it away from any hard-coded decision and making it parametric through your own sliders, they could be very interesting for people to really get in here and have fun generating some surfaces. And that's why I'm taking those and making those Wickerson Studio kind of plugins. I guess I can refer to them now as that. So enabling, you go on in and you have that Ripley mesh. If we go into the mesh tools, Ripley mesh node, there it is. It's just a matter of plugging in and setting your parameters differently and kind of understanding what I mean by size as integer compared to probabilities between 0 and 1 and modulus as what's the dividing factor. You could jack that up a lot, the modulus, but it also will work very interestingly at low numbers, odds and even numbers. 0 is not going to work as a mod, so I'm just going to pull that one down if I can. Nope, it doesn't like me enough. Let's pull it into that. You can see that there's a very strange modulus form. It doesn't really do anything for me. There we go. Really got a nice jump from there as to nothing happening to something very special happening. Nice form. Anyway, the node's up and ready, and I'm willing to share, and we'll see where it goes. Let's do the last one, which isn't actually the last one I want to do. We're going to get hard into trigonometry after this, and I'm very excited about that. This one I may do again. This is an and/or conditional, and you'll see there was a lot of choices in this script, which I didn't leave the original up, but it was using similar script to the one before, but basically enabling. I really wanted to have these kind of percentages as they rotated through as to what they might do. It's hard to reference what's happening in the points, but the mesh really cleans up the edges. And to me, I've got this crosshair that I can go in as percentage E. I can set the size and scale of everything, but the midpoint is really where I put that crosshair, almost like a multi-dimensional slider lofting up. And you've got this control of really coming in and flattening things, like not only changing the size and scale at 100 by 100, you can start to multiply that. But here's where you start to flatten things, like have something that overpowers as a conditional and says, wipe out all that geometry. And I call this kind of a temple in a sense of, okay, where would I grab that 33 value? I jumped down here to 38, but I could start leveling, like terraforming on this sense of bulldozing that flat. So geometry tied to data and numbers starts to become a very interesting thing. And there's the midpoint moving and shifting, just jacking things up and down by a little point, kind of like a leveling fence, kind of like to quarter the yard. And then you're also able to push this back and undulate and fold and move things up. And because of these percentages, I call them percent D, percent C, they're pretty interesting. And then your heights are an amplification of smaller number that you can really jack up a pavilion or a building. So this to me is, if I bake that, a very interesting kind of rendered geometry. And we'll just take it into something like leave the grasshopper. There we go. We've got this kind of cloaked, draped cloth of something very weird done in meshes. And I just love these geometries and ramps and what it could possibly be for gaming or other designs. And fully parametric model, which is called an and/or conditional mesh at Wickerson Studios. So I hope you enjoyed it. If you do find something that you like within it, and you want to bake it and render it and send me a picture of it, I'd be pretty happy. Got a little bit of materials here. We'll grab a little glass gem. I'm not so much in the transparencies anymore. I knew that would wear off on me sooner or later. Let's do a plaster and just grab a really dark color like that, and grab that and just set our colors. And there we go. Leave that. There we go. Very eerie kind of field of a place to be that's really driven by the simplest of data, looking very similar to a Python script that doesn't deviate too much from that. Just dealing in hard coding and doing a range of points and creating things from a series of points. I hope this makes a bit of sense. My next goals will be to go in and really do some trig functions, and as I get better, you'll find this is generating not just points for curves and meshes, but actually curves themselves, meshes themselves, surfaces, and breps, and then we'll see where we go from there. So thanks again for watching. It's all coming. It's all tied to ARA Jewelers and what's happening there, which is very exciting for me as well. I'm not sure where that went. There's my little ring there. Nice little monolith bridge for my little gaming space. So nice little ending just to blow you away and still go in there and say, oh, well, what if I take those values and throw them through another iteration? 4 was working for me, but let me pop that one up to the iteration 7, which is literally 0, 1, 2, 3, 4. It's probably a 1 there. All right. I like playing with data, and I like data driving forms. Thanks very much for watching Wickerson Studios, and talk to you soon.